Okay, here's a technique called completing the square, which will help get things the form we want them. So if we look back at the trigonometric relationships we've got, when those things are integrating, they're all to do with squares. So difference between squares or sum of squares with square roots in them. Okay, so if we can get the thing we're trying to integrate on the bottom line to be something squared plus something else squared or minus, then we can do it. And this technique of completing the square should help us to do this. So this is a formula that does it, but personally I never use that formula because it's too hard to remember. I just work my way through it. So factor out the front. So we give us minus x on 3 plus 4/3. And then that's equal to x minus, in this case, 1/6 all squared plus 4/3, because if we expand this bracket out, we get x squared minus 2 lots of x on 6, which is x on 3, plus 1/36, which is random, so we have to subtract an extra 1/36, so that we're not introducing something that we don't want, and then it's just a matter of tidying up. So we've got 3 lots of x minus 1/6 squared, plus that's 48 over 36 minus 1 will be 47 over 36, and we want it as a square, so we've got 3 lots of x minus 1/6 squared plus root 47 over 6 squared. Okay, so I've now written this quadratic as two things squared with a factor out the front, and this looks like the form I want for the bottom of my integrals.